Hey all, welcome to my channel. I'm the Printing Pilot, and in today's video we're going to talk about the mic we're using for our channel, and also how we added some features to the mic using 3D printing. We're going to talk about SolidWorks, how we design everything, and we're also going to talk about some manipulation we do in the CAD software so we can add some other features in the slicing software. So let's start with the video and let's make everything. So the first part of this video actually started before YouTube. So what I mean is I released those designs on my Printables and Makerworld channels, and I started talking with Fifine, the manufacturer of the mic, and they really like the idea of designing stuff and adding more features to their product. So we started having a relationship. Now there's no money exchange between us, and at the time when I bought this mic, I paid it for my own money, and also, so all of the decision about what I'm trying to say that I made about purchasing this mic and my other problem with purchasing another mic was made with the budget that I gave myself for this project. Now, at the time of recording this video, Fifine refunded me for this mic, so just full disclosure, they refunded me for the mic, so they basically sent me the mic, but there is no money exchange, so everything I said is my opinion. Now, in this channel, in my videos, I'm not going to really do reviews. That's not what we're trying to do. But we're going to have a quick review of that and why I chose that mic. And then we're going to talk about the design process and what we are achieving with those functional 3D printing parts. So the main problem we had is that I knew I'm going to need to buy another mic. The idea was this is going to be a mic that I'm going to use in front of the camera. If my wife want to join me, or if a friend from the 3D printing community want to join me, this mic comes with two mics. I can just give them the mic and record. We're planning in the near future to go into 3D printing conventions, and we want to interview people and have people on the channel. The idea was that going to a stranger and giving them that mic, or trying to, maybe help putting that mic on the shirt might be inappropriate or uncomfortable, when a stranger come and touch your shirt. So the idea was I will need probably another mic that I can hold and just hand to someone that would be much easier for them and more comfortable for them to start and having the interview with me. So while purchasing that mic, I knew that in the near future I'm going to have to buy another mic. So why I chose that mic was part of combining those two prices of the two mics to fit into my budget. So getting that out of the way, Fifine refunded me. Let's start with talking about the mic itself. So this mic is a lavalier style mic, and it comes with a receiver and two transmitters. So basically two microphones and a receiver. Now, you don't see them here because the other mic is on my shirt and the receiver is connected to the camera. So what you hear right now, it's me speaking through that mic. And at this point in time, while recording, I don't do any editing to the sound. Maybe in the future, it just seems to be a lot of stuff to do. So this is raw recording from the mic. This mic have about 6 hours of battery with a 150 milliamp battery. That's what Fifine claims. I haven't tested it. The longest I think I used that mic was for about 2.5 hours, so there was no problem with that. The receiver has a 280 milliamp battery, which give it about 12 hours of battery. That's also something that came from Fifine claims. I haven't tested it because I think recording straight for 12 hours, it's insane. But for a regular session of me doing 2-3 hours of meetings and whatever, more than enough. Case itself has a 1200 milliamp hours. So basically, if we do a quick calculation, it will give you about 2 full charges for the two mics and the receiver on one charge of the case. And of course, the case can charge the mics and the receiver at the same time. Now, both of these stuff are very regular functions for any lavalier style mic that comes with, the receiver and two mics. The case will charge it. while I was looking at buying lavalier mics, there was two main price points, where something that was very cheap and didn't look like that, looked very small. And there was stuff that looked and had this charging case and everything, but they cost about 300 and north than that US dollars. So that was too much for me because I wanted to spend that amount of money for two different mic systems. So when I encountered this mic, I was thinking to myself, the price was $60 at the time, and I think it's still $60. And it was not only extremely cheap, but came with all the features of the big company mics. So I was like, I'm gonna buy it from Amazon, and it's going to be or the best product, or it's going to be a huge failure because it's $60. And yeah, I love it. So let's continue. The polar pattern of the microphone is omnidirectional, which is pretty standard, with a frequency range of 20 Hz to 20 kHz, which is also very standard. I don't have any ways to actually test any one of those, but I mean, for this quick review, we'll take Fifine words for it. Range, they're claiming 50 meters of range, line of sight. I'm not going to test it because I think 50 meters is crazy. I mean, if I go 50 meters away from the camera, you guys won't be able to see me. We're going to do a quick range test pretty soon, and we're going to talk about their noise cancelling feature, something that I haven't tested, and we're going to all see it live and see how that affects the sounds, because it's probably going to affect the sound. But having a wireless system that works, I would say, up until 5 meters from the camera, which is about 15 feet, and work reliably with about, I think they're reporting 20 to 30 milliseconds of delay, it's more than enough. What we do have on the mic is we have some independent volume control, so we can change the volume control on the mics itself between two of them. We can do mono or stereo recording if you want to have stereo recording with those two mics. And we already said about the noise cancelling feature. So let's go outside, do a quick range test, and then move on to the CAD portion of this video. Okay, so now let's take a walk while I'm talking to the mic. Right now, noise cancelling is off. We're going to walk about 15 meters away, which is about 45 feet. I'm going to turn around. So probably right now you basically can't see me. So let me just turn on the noise cancelling. So noise cancelling is now on, and after editing we'll be able to see the change in volume. So I'm going to walk back, and noise cancelling is still on. That was about 45 feet away, 15 meters away from the camera. So let's go back in. So coming back in after using this mic for a couple of weeks, I really enjoyed using it and I really like it. So I was thinking to myself, this mic is already wireless and it comes with all the features of a wireless mic. So maybe I can design something for it and expand its capabilities in a way using practical 3D printing and practical CAD design to take that mic and make it something that I can hold and hand to people for interviews. So let's go to SolidWorks, let's try and design something for it, and we'll talk about it there. Now this is the mic handle itself, and there is a few important stuff here I want to talk about it. So first of all, this is the shorter version, not for the flag system, but it's basically the same model, just with a longer handle. So let's go back in our design tree and talk about what we're doing. So basically what I did, I just added this shape sketch surrounding the mic. Next thing I did is just adding a cutout for the actual mic. Now next thing is actually starting to work on the part that the mic going to clip into. So let's hide this part and start to look at what we are designing in here. So we started with those three straight pieces, and the mic itself is going to be held by sliding into the spaces between them. So I started adding chamfer here, and I want you guys to see something really important. So let's do a section view really quick. So while talking about designing something, and that's something that I always used to do, to tell the engineers and the intern that work with me, is that a good engineer is an engineer that designs something while thinking about the manufacturing process. Because I've seen people designing like really, really amazing stuff that can change the way we think and the way we do stuff. But if you can't manufacture it, then that design doesn't really mean anything. So we are going to use 3D printing, additive manufacturing. And this entire print is designed to print on this surface. So it's basically going to print like that. I added this chamfer because while printing, what's going to happen, we don't need support. So we're going to have an overhang, but it's going to be only one line from here to here. And then on top of that line, slowly we're going to start building all the other layers. So by chamfering it like that, I don't need to use support. We're going to have an overhang, and it's not going to be the most pretty overhang, but since it's a practical print and it's inside, you won't be able to see it. So by doing that, I made this print much easier to print, no support needed. And that's something that as a designer, we should always think of how we're going to print it, how we're going to manufacture it, and add features inside of our print, inside of our design that will actually make the design printable. So let's go back here and let's move on. So next thing is we added fillets and chamfers inside, and I want you guys to see this portion. So if I go back here, we added a fillet here. And all of these surfaces, by adding a fillet for them, they have, before the fillet, you have a 90 degree. So you have two surfaces that touching each other with a 90 degree, which basically make a very sharp corner. Those sharp corners actually is a stresses of forces and can actually break really easily on that portion. So by adding that fillet here, we are making this part really like much more stronger. Adding those chamfers at the edges, that's something that I always see people missing when they design in the designs online, is chamfers on the edges. So the same thing, when we're talking about the external edges, we are going to have a 90 degree sharp corner. Again, we're going to have forces concentrated in that point, and it's not only going to be sharp and not fun to touch and handle, but if we, let's say, drop that part, when that part going to hit the ground, it's going to break or chip. And right now, by chamfering this area, it's not going to do it. It's going to look better. It's going to be easier to hold and handle with our end. No sharp corners. And overall, it's going to make the product be better. So always chamfer and fillet your corners. Let's move on. The next thing is that we did is we started to work on the handle, and I was thinking to myself, how can I make a transition here? It's going to look, nice. It's going to look seamlessly. And I was thinking about doing complex shape, but I was thinking to myself, let's try and fillet something, because that's going to be the easiest thing to do. And I started to add in this huge fillet here. And while looking at it, I was thinking to myself, okay, it's going to work. It's going to be much easier. So I started to add in more fillets all around until we were able to get this nice transition. Now here we have multiple surfaces, but that's not something you guys are going to see in the actual STL. It's going to be a nice transition. And then all I added after that is just cosmetic stuff, the Fifine logos, both ends, but that's basically it. Now, there is one thing I want to talk about it before we move on. And for us to do that, what I'm going to do is I'm going to hide all of that, and I'm going to export it to Prusa Slicer. So let's wait for that. So while working with Prusa Slicer at the time, which was about a couple of weeks ago now, Prusa Slicer added a thing that's called fuzzy skin, paint on fuzzy skin. So while printing the first prototype, it was very nice and very smooth. And I was missing something like friction, something that I can like knurling or something like that will actually give me some grip. And that's when exactly the day that I got that Prusa Slicer update, and now we can actually add something that's called fuzzy skin. So we can paint on the fuzzy skin, And while we slice it, the slicer is going to add this fuzzy skin on top. But we had a problem here. No matter how hard I'm going to try, I will never be able to make this thing straight, a straight line here. It's a cylinder. I need to move it with the mouse in space, and I would never be able to like make this thing straight. So I was thinking to myself, I want it to look like a finished product, really nice. Add really nice fuzzy skin to it. So next thing that I was thinking is, how can I manipulate the actual slicer, that I can use it as a face, add a face to where I want the actual fuzzy skin to be, so it will look straight and it will look professional. So let's see what I did here. I basically started with designing one big circle, and one circle that it's just slightly smaller than the diameter of the handle. And I'm going to cut those two surfaces. Now, basically, if you think about it, I'm adding a groove. I'm grooving the handle. So think about it like putting this thing in a leaf and just adding a groove here. Now, the groove that I added, as if I look at the feature, is very tiny, is 100th of a millimeter. So what we see here, we do see that groove here, but since the slicer is going to slice on a 0.2 millimeter and 2/10 millimeter height, that groove is something that we're not going to see. The slicer is going to disregard it. So by adding two of these grooves, one on top and one on the bottom, what I made is actually a face. I can choose that face. So now, if I'll save it, I'm going to close this. If I save it and I extract it into Prusa Slicer again, and I can also align it the way it should be aligned and printed. Now if I go to Fuzzy Skin and I do Smart Fill, look what happened here. I have this face here that I can just choose. I don't need to paint, and it's going to be perfectly straight. And now when I slice the project, I have this perfect fuzzy skin wherever I want it. So sometimes we do this weird manipulation in the CAD software so we can add stuff in the slicer itself. And now if we're going to take a look at our design, as we designed here, that overhang is going to be a one line, and then slowly everything is going to build on top of that line. So looking at this assembly, we're now going to talk a little bit about the mic, the flag system. So the flag system is made from two main parts: the actually base, the body of the flag system, and the individual customizable magnetic tiles. Now, talk about the flag body itself. I don't want to go step by step here, just because this video is going to be like 2 hours long. So just a couple of, or one or two really important or cool stuff, in my opinion, in this design. First of all, is this compliant mechanism. The way we designed it, it should press fit and slide into the handle inside of it. And the way that that thing works is when you have pressure in here, that entire thing is going to deform towards this cavity in here. And basically, it's going to be like a spring, but it's all 3D printed. So that's what will give you the pressure, and it will actually hold the entire flag system on the mic. But also it will be it's also going to touch not on this entire surface. It's only going to touch like on this portion on the mic. So in one end it's going to have that friction fit, but on the other end it's going to be too difficult to remove everything. So it is designed to deform. We also add a cutout here on top of this circle, because we're printing it like that standing up. The circle is not going to be perfect. We're going to have overhangs. So that way I'm just moving the overhang a little bit up there. So this circle is going to be as perfect as it can, but because of we're printing it vertically, we're going to have some dimensional inaccuracy. So this portion, probably the best way to go about the magnet is actually adding some glue to it. But that's basically it. I don't want to go into more details. So let's continue, go to the slicer and talk about actually how to add your logo into the actual tiles. So let's talk really quick about the faceplate themselves. Now the faceplate are actually going to be printed face down like that. So the face with the logo is going to be printed on the build plate so we can have the best surface finish and the best logo. But let's go back just for us to be able to edit it easier. So the way that we are going to add our logo is we need to have our logo in an SVG. The way we do it, we're going to right click on the model, we're going to add a modifier, and we're going to add an SVG. So after finding our logo, this is what we're going to see. So we have this panel here and we need to change some stuff. So first of all, we're going to make it much smaller. And now we're going to be able to move it. Now you guys can do it, move it and, place it wherever you want to place it. Depth, I'm gonna, since I'm printing on 0.2 layer height, I'm gonna make it about 3 layers height. So let's make it 0.6 to 0.8. So that's how deep it's going to go. I'm also going to say use surface and make sure it's on the actual surface and not inside of the part. And now I'm just going to maybe just make it a little bit bigger and you can move it around, but that's basically it. Make it about 3 to 4 layer height inside of the model. Use the surface so it will be flat on the surface. Just move it and make sure it's on a modifier and not cut or joint. Now, to actually make it multicolor, I'm going to right click on that. I'm going to do change extruder and let's choose orange. So now if I slice it, I can actually see the logo on the actual tile. It's very simple to do it on Process Slicer with the SVG modifier. But for us to print it, now we need to put it onto the bed. And while it's printing on the texture build plate, it's going to print like that. So 3 layers and then everything else is going to be black. And we'll be printing on that surface. We're going to have this surface in the print. And we're going to get this beautiful, beautiful logo on our tile. So that's basically it. We talked about the way we design stuff, why we chose some of the feature, how we always think about the manufacturing process. And that's like really showing you guys step by step how I was thinking, how I designed stuff, and how do I got to this state. So let's go to the printer, print everything, and let's cue the time lapse. So in our design, as we saw in the design process, we have 2 different lengths of handles. So we're going to start with the smaller one, and just to put the mic in is as easy as it can be. You have that clip here, and you just slide it in and push it until it snaps into place. You hear a click, and that's basically it. Now we're going to talk about covers pretty soon, but for now, let's go and move into the longer hands, and that will be the handle that will use the flag system. So for now, let's try and assemble the flag system. So the flag system itself, as we talked about it in the CAD, is combined with 2 main parts: the housing of the flag itself, and then the interchangeable magnetic logo tiles. So for assembling them, all we have to do is all we need is just some magnets. Those are 10 by 2 millimeter magnets, and of course links for everything going to be in the description below. And all of the fit here should be friction fit. It also depends on the dimensional accuracy of your printer, but the way that we're going to do it is we're going to try or just press it in with our just with force, and as you guys can see, it's all the way in. But what I like to do is or to press it against a flat surface. That way we make sure it's all the way in. But if you don't want to damage your desk, I'll just take a screwdriver or something and give it a tiny squeeze and make sure it's all the way in, and that's how it should look like. it should be flushed with the surface, and hopefully it won't get out. So we're gonna test it. The next part of the assembly will actually be to press it into the flag base. And because of the shape here, this is going to be a little bit more complex because you can't really press it down against something. So again, I'm going to use one of the tiles to check the polarity of the magnet. So we're going to do it the other way. And now I'm going to try and start with pressing it. And that was actually pretty easy. I thought it's going to be much more difficult. And I'm going to give it one press all the way in. And before I'm going to continue with everything, I'm just going to test this portion. Fail. Now it's in. So I'm going to try and put it in and snap it into place a few times to make sure the magnets and all the dimensions are correct, so the magnets are not flying away. And the way that I design, and we talked about it, of course, the design portion, is I added those chamfers here, and we have a chamfer corresponding here. So basically when you put the magnet in, it's flush with the surface, you don't see it. But because of this chamfer, when you press it on one side, nothing really happened, it just jump a little bit. But because we don't have that corresponding chamfer here, when you press it in here, it will jump out. It will fall. It depends how strong you are, how much force you put in at that point. But it could fall or just pop out like that, and then you can take out the insert. So yeah, let's do it 3 more times. And if one of the magnets is just falling out because of the dimensional accuracy, the way we print everything, just add a dab of CA glue. Just hold it like that for a few seconds, let the CA glue to dry, and that's basically it. So we talked about this portion in the CAD system. So we have that compliant mechanism in here that's designed to compress and be flexible. So all we have to do now is marry the two assemblies. We're just going to slide that thing in. We're going to have some unpleasant sound for a sec. Sorry about that. And it will stay in place and it won't move. Now all we have to do also, the last part, is to add the actual magnetic tiles into the assembly. And it will snap into place. It's very satisfying and it's going to stay there. And now you have a mic system for interview with a mic handle, with a flag system. So now all we have to do is add our mic into the handle, snap it into place like that. And the really cool thing is we got these wind protectors that you can put on top of your mic. And now it really looks like a mic from like the news, so you can interview stuff. Now this should be connected. Let me just check. Yes, it is connected. So if I'll move that mic for my wife, maybe we can hear her. So is it working?
It's working. This is the wife.
Yeah. Do you feel like you are?
I feel very interviewed right now.
You feel very interviewed.
Well,
so
also maybe as an interviewer, I'm feeling professional right now. I'm ready for my debut. That's
the goal. So for conclusion, we took our lavalier style mic that should go on your shirt, and with functional 3D printing and some CAD design, we designed those handles that will make it to look and function as a regular handheld mic. We also added a flag system to it so we can mark ourselves with some logos and everything. And we added 2 different lengths of those mics. One of them is going to be the shorter version that's going to be more lightweight, and the other one is going to be the longer version with the flag itself and the wind cover. So that's something I really like in 3D printing. You take something and you give them more functionality with just basic design and a 3D printer. So in the future, we're actually going to have more videos coming with working with Fifine, and we're going to have more of their products coming over, and we're going to solve some of the problems with CAD Design and also add more functionality to them. So I think that's going to be really cool videos to show you guys the process behind me designing something, working on SolidWorks, and going from the computer to actual physical product. So of course, all the files for everything you see here are available for free in our Printables and Makerworld page. So please go check it out, and hopefully you guys are going to make one of them. But if you do make one of them, post a make. I would love to see it. So with that, that's going to be the end of our video. Thank you very much for watching the video. If you like the video, smash the like button and make sure to subscribe. More really cool projects are coming in soon, so we'll see you on the next video.